today's problem from differential equation, and this problem from linear differential equation which is non-homogeneous and with constant coefficient. We first write this differential equation into its by using differential operator, that is by using D, and we know that this type of equation has general solution. It has two parts. The first part is, if y be the general solution, the first part is yc and the second part is yp. And first part, this is complementary function, and second part, this is particular integral. Okay. Now we here derive all the part, that is complementary function and particular integral one by one in detail. Okay. To find the complementary part or complementary solution or complementary function, we let y, this is equal to c e to the power mx be trial solution. Okay, this is the trial solution. So we get auxiliary equation. Auxiliary equation is given by, this is m square minus 1 equal to 0 by putting m in place of d in the homogeneous part only, and the right side be 0. Okay, so we get two value of m, these are plus minus 1. Okay, so two roots of auxiliary equation are real and unequal. So the complementary function yc, this is a e to the power x plus b e to the power minus x. Okay, very easy. This is the complementary function. Now we know about the particular integral. Particular integral of a differential equation of the form f of d into y, this is equal to x, is given by yp, this is 1 by f of d into x. Okay, here we get the particular integral for this differential equation. This is given by, here f of d means d square minus 1, and x, this is x e to the power x sin x. Okay, now we use the rule to find the particular integral if the x, that is the function of x, is of the form e to the power x into x sin x. That is, we use this rule. Yp, this is 1 by f of d e to the power ax into v of x. This is the function of x, and we get that we write e to the power x in the left side of the operator, and operator becomes d plus a in place of d. Okay, so we write here first d square minus 1, and then we write e to the power x into 1 by d plus 1 whole square minus 1 into x sin x. So e to the power x into 1 by d square plus 2d, and this is x sin x. Okay, now we find out the particular integral of this type, that is, we find out the value of this. Okay, to find out the value of this, we first put, this is given by q, and this is 1 by d square plus 2d into x sin x, and here p we let, this is 1 by d square plus 2d into x cos x. Then we get p plus iq, a complex number. By taking common, we get d square plus 2d into x cos x plus I sin x, right? So this is d square plus 2d x e to the power ix, because this is the Euler form of complex number. Now again we use this method, that is, we write e to the power ix in the left of this, and d becomes d plus I. So d plus I whole square plus 2 into d plus I into x, right? So we get e to the power ix 1 by d square plus 2id plus I square plus 2d plus 2i into x, right? And getting the result as e to the power ix 1 by, this is given by d square plus 2i plus 2 into d, and this is given by 2i minus 1 into x. Okay, because I square, this is equal to minus 1, we put here. Now taking common 2i minus 1 from the denominator and getting the result e to the power ix by 2i minus 1, and we write 1 plus, this is given by 2i plus 2 into d plus d square by 2i minus 1, this is to the power minus 1 into x. Okay, now we write the expansion or infinite series expansion of this series. This is 1 plus x whole to the power minus 1, and we know that 1 plus x whole to the power minus 1, which is given by 1 minus x plus x square and so on. So we write e to the power ix by 2i minus 1 into 1 minus 2i plus 2 into d plus d square by 2i minus 1 plus and so on, we get this is x. Now if we operate d on this, we get the result. We write here, this is given by p plus iq, and sorry, we write in the left p plus iq, this is given by e to the power ix by 2i minus 1, this is, and this is x, and from here we get this is 2i plus 2, and d of x, this means 1, and d square of x, this is 0, so this is 2i minus 1, and all the other term are 0. Okay, so we cannot write, or we not write all the other term. We get only this term, that is the differentiation of x first time, and the higher order differentiation of x are 0. Okay, now we get the result as e to the power ix by, also we take common 2i minus 1 from here, we get 2i minus 1 whole square, and this is I into 2i minus 1 minus 2 into I plus 1. Okay, so this is given by e to the power ix by expanding this square, we get this is 4i square minus 4i plus 1 into, this is given by, sorry, this is not I, this is x. We take common I from here, we get 2x minus 2, and write the another term, this is x minus, sorry, x plus 2. Okay, and getting the result as e to the power ix by, now putting the value of I square, this is minus 1, we get the result as taking common minus from here, this is 4i minus 3, sorry, plus 3, and these two terms remain same, this is I into 2x minus 2 minus x plus 2. Okay, and to eliminate I from the denominator, we multiply numerator and denominator by 4i minus 3, and getting the result, this is e to the power ix into 4i minus 3 by, this is 4 square minus 3 square, this is minus 4 square minus 3 square, because I square equal to minus 1, so this is equal to minus 25, because 4 square is 16 and 3 square is 9, and the remaining term same, I into 2x minus 2 minus x plus 2. Okay, and we only find out the value of q, that is the value of imaginary part, because this is a complex number p plus iq type, So we have to find out only that imaginary part. So to find the imaginary part, we write this is 1 by 25 and e to the power ix. This means cos x plus I sin x. Okay, and if we multiply by 4i, we get the result as minus 4. This is 4i into I into this. So we write minus 4. This is minus 8 into x minus 1. We take common 2 from here. And from here we get this is minus 4i into x plus 2. And this is minus 6i into x minus 1. Okay, and this is given by plus 3 into x plus 2. Right, this is by multiplying 3 with this. Now we write the value of q, that is the imaginary part of p plus iq, that is imaginary part of this side, and we get imaginary part as 1 by 25. If we multiply cos x with the real part, then we get real part, and if we multiply cos x with the imaginary part, then we get the imaginary part. Okay, so we get imaginary part from here. This is minus 4 into x plus 2 into cos x, and from here we get minus 6 into x minus 1 into cos x. From here and here we get imaginary part, and another imaginary part we get by multiplying I sin x. So sin x, now write plus sin x into, we write this is given by minus 8 into x minus 1, and from here we get this is plus 3 into x plus 2. Okay, this is the imaginary part of the above expression, and we take common from here also cos x. We write this as, right. So q is given by 1 by 25. From here we get minus 4x minus 6x. This is minus 10x. This is minus 8. This is plus 6. So we get this is minus 8. This is plus 6. So we get minus 2 into cos x, right? And from here we get the result as plus, this is minus 8x plus 3x, so minus 5x, and plus 8 plus 6, this is plus 14 into sin x. Okay, so by taking common negative we get the result as 1 by 25, and this is minus 2 5x plus 1 into cos x, and this is minus 5x minus 14 into sin x. But this is not our final answer, because this result, that is the value of q, we here put, then we get the total total particular integral. Okay, so yp is given by, here e to the power x present, so we write e to the power x by 25. Okay, and we write this term at the first by 14 minus 5x into sin x. Okay, and this term 2 into 5x plus 1 into cos x, and this is our total particular integral. Okay, now we add yp and yc we already find, and getting the general solution as y, this is equal to yc plus 1. This is the total solution, and this is lengthy type of particular integral, and very important problem also of this chapter. Thank you for watching.